Hello everyone, today we will be looking at creating a surveillance camera system inside of Unity. This system uses colliders and it will ray check to see if the player is behind terrain, so that if he is inside of the collider on the camera, it will not show that he is there if the camera is not able to raycast directly to him. These cameras also have a adjustable pan, so you can change how far they want to pan back and forth. You can change the pitch as well on start, so you can decide how high they are looking or how low. And they also have a variable for how fast they do their rotation and how long they wait at the end. So to start this off, I'm going to create a new scene. I suggest you do the same, and I'm going to quickly drag out a prefab that I have previously built. This is just a load of empty game objects and cubes. You will have to create one yourself. I'll just give you a quick run through of what this is comprised of. The highest most parent object, the camera, is just an empty game object. This is just a position for us to be fixing this to whatever wall it is that we want. As a child of that, we have the neck, which is just a cube, as you can see here in its transform. There are its rotations and scale values, and it's just to represent the neck of the camera. We also have, as a child of the camera pivot, which again is another empty game object, and this is just used so that when the camera is rotating, this is our rotation point. I'll just round that off back to 0. As a child of the camera pivot, we have the graphics, which is this blue box, the body of the camera, or at least representing that, which again is just a cube that has been scaled. We also have the lens on the front, and that's the thing that was changing in the scene, the thing that was changing red to show you that the camera could in fact see the player. And on top of that, we also have the frostrum, which is a box collider that has had its mesh filter and mesh renderer taken off and scaled to give us effectively this is representing the view of the camera. This will need to be put on the ignore raycast layer up here on the top right. Just want to go in, it'll be on default, just select ignore raycast and select that for that. I'm just going to quickly go back through these to make sure there's nothing special about the rest of them. Nope. So if you just want to quickly make something like that at all, you could just make the camera pivot and the graphics part, the lens and the frostrum, and that will work fine. The neck and the actual camera part is just for it's just to kind of give a bit more of a visual representation of the entirety of a camera. We will also need a player object to go with this, and I will drag that in from the inspector as well. And this is simply just a capsule. You can go and create 3D object capsule. I've gave it a blue material and it has a rigid body attached with the gravity turned off, and it is also tagged player. So if you want to just create one of them, just make sure it's tagged player, it has a rigid body, the gravity is off. You can give it a material if you want, you don't have to. And with that, I will also just be bringing in a wall, which is just another cube that has been scaled, and this will just be used to block the view of the camera, just so we can see that it is actually working later on. As I said, that's just a cube, nothing special on it at all, just a scaled cube. So from here, what I'm going to do is start coding out the camera's functionality. To do that, I am going to go onto the camera pivot and I am going to add a new script, and I'm going to call this cam rotation, and this will be the script that deals with all of the rotation for the camera. Just going to double click that and open it up. When we finally get there, come on, you can do it. Where are we? It hasn't opened. Let me just go back there and double click that again. There we are. Now we are in. And to do this, I'm going to do the rotating of the camera in a enumerator. So to start doing that, I'm going to quickly change this update to an enumerator. I enumerate, and I am going to call this rotate. And this is a function that is going to deal with all of the rotation of the camera in one go. Just for right now, I'm going to quickly start I'm going to type in start coroutine, and I'm going to type in rotate, so that on start this coroutine will be called, just so that we can actually see it working. And to get this working, we are going to need a few things inside of the rotate. It is at saying, oh yeah, that's fine. Don't worry about that being red there and we're having an error. We'll fix that later on. We will need a quaternion here, so I'm just going to type in quaternion. I'm going to call this initial rotation, and this is going to be equal to transform dot rotation, and this will be used in the angle axes method to calculate our position. We are also going to need a timer in here as well, as this will be done over a set amount of time. So I'm just going to create a float, and I'm going to call that timer, and I'm going to make that equal to 0, so that each time we come through, this is set to 0. And we are going to do the actual rotation in a while. So I'm just going to type in here, while timer is less than a number that we have not created. We're going to want to pass a value into the enumerator here to deal with this bit. I'm going to call this duration in the while loop, and at the top I'm going to create a float and call it duration, and we will pass in a float to be our duration, which we will create at the top right now. So just at the top, I'm going to come in and I'm going to make a public float so that we can adjust it in the inspector. And I'm going to call this seconds to rot, which is just representing our the amount of seconds it will take for us to actually rotate. In the start method here, where we are calling the coroutine, I'm going to quickly just pass in seconds to rot, and that will work as our duration in the while loop. So in the while loop, to actually get this working, we are going to make the timer plus equals to time dot delta time, and we are going to want to change the rotation of this transform. So we're going to say transform dot rotation is equal to our start rot, which we our initial rotation, which we created just at the beginning of the enumerator here, and we are going to multiply that by quaternion dot, that was meant to be a multiply, quaternion dot angle axes, and inside of this we are going to say timer divided by our duration multiplied by a value we are going to need to declare to dictate how far we are going to be panning, and I am going to call this variable yaw. So just above where the seconds to rot is, I'm going to create another public float, and I'm going to call this yaw. Don't have to give it a value right now, we'll do that in the inspector, and we will use this yaw right here and multiply this by the yaw, and this will give us the amount that we want the camera to rotate. We are also going to need to give this vector 3 dot up and then close that off. And before we finish this off, because it is an enumerator, we are just going to say yield return null. And with this, I'm going to give this a quick save and head back into Unity, and I'm going to quickly just go onto the camera pivot where the rotation script is attached, and I am going to give it a seconds to rot of 2 and a yaw of 90. So what this should do is rotate to its right, I do believe, by 90 degrees over 2 seconds. I'm going to quickly press play and just check to see if this is in fact working. As we can see, that has rotated 90 degrees over the 2 seconds. So it is working as we want it to. From here, I would much rather have the coroutine being called in an update method that is going to check a few variables so that it will switch between both the panning one direction and then panning the other itself without obviously just being called once. So I'm just going to quickly below the start create a void update, and in this I am going to make an if, and we are going to check a few boolean values here which we will need to create. So at the top above the float yaw, we are going to say bool start next rotation, and we are going to start this off to be true, as this will need to be true for us to start actually rotating from the beginning, and we will need a second public bool, which I am going to call rot right. And this will be, if this is true, the transform will rotate right. If it's not, the transform will rotate left. So in the update, we are going to use these two to decide what way the camera should be rotating. So we're just going to quickly say in the if start next rotation and rot right, if both of these are true, we want to call our coroutine, which I am going to quickly strip out of start and paste into the update, and we are going to want to use the seconds to rot, and we are going to also want to pass it a second value to the rotate, so that this yaw value is not just set straight from here. So I'm going to quickly go into the rotate, and where we have float duration, just before that I'm going to create another float called yaw. Of course we are going to have to come into the rotate here, and we will have to give this the yaw first before the seconds to rot. And this will allow us, when we change this every time it's finished this rotation, we will be able to change the amount it is rotating. With this if, we are now checking that if it does want to rotate and it wants to rotate right, it will do so. We also need an else if below this to check if our start rotation is true and rot right is not true, which means we want it to rotate left. I'm just going to copy this start coroutine call in the update, and we are going to feed this, in this instance, the negative yaw, so that it will go back the other way. And for these to actually work, these booleans, we do need to use them in the rotate enumerator. So just at the top, we will say start next rotation to be equal to false, and just below it we will say start next rotation after the while loop, sorry, is equal to true, so that once we have fully rotated, it will the true value will be passed to these, so that it will know that it can start a new rotation. And we will say rot right is equal to the opposite of rot right, and what this will do is whatever whether it be true or false, the opposite of it will be changed to the opposite every single time we go through. So I'm just going to give it a quick save and head back into Unity, and under the cam rotation script we should now have the rot right variable. So if I do not have this selected, the camera should rotate left as a start. I'm just going to press play and see if that does in fact happen. And as we can see, it is rotating 90 degrees by the 2 seconds, and it is going back and forth because those boolean values are working fine. But as we've seen, when the camera is initially down, it is facing forward and it is panning 90 degrees only to its left or its right, depending upon what this boolean is set to. I would much prefer that when the camera is forward, like so, it would pan 90 degrees from its current position. So to do that, we're going to have to change the actual initial values of the transformed rotation. So I am going to head back into the code, and in our start method, I am going to create a function called setup start rotation. So I'm just going to type in the start here, setup start rotation, and we don't need to pass that anything. And just at the bottom, I'm going to create that. So void set up start rotation, and inside of here we will do a few changes to the initial rotations of the transform. To do that, we will also need to use the rot right boolean. So I'm going to say if rot right. So if rot right is true, we want to change the transform dot local rotation to be equal to quaternion dot angle axes, and we are going to give this the yaw in this case because we want to offset it in the opposite direction to which we are starting. So in the update we had the rot right saying we wanted to give it the positive yaw. Because we wanted to go the other way, we want to give it the negative yaw divided by 2, so that it will pan over the essentially what will be an arc, and we want to give it vector 3 dot up as well. We also want an else below this. You can create this as an else if to see if it is not right, but of course the only other option, this is either true or false, so you don't really need to. But in the else, I am going to say, and I'm going to quickly copy this transform.local rotation here, paste it in, and we are going to give it the positive yaw. And what this will do is when we start it up, have we called it in start? Yes, we have. When we start up, whatever this is set to, as you can see, rot right is not true, so it will want to rot left. So I'm going to quickly give it a value of 180, so it's really easy to see. What this will do is rotate us by half of the value to the right, and it will pan in a 180-degree arc directly in front of the position the camera is now looking at start. And as you can see, it is rotating the 180 degrees over the 2 seconds. If I change it to 5 seconds when it starts again, as you can see, it drastically slows down. So that's all working fine and dandy. There is a few things I would also like to change in here. I would quickly like to, in the eye enumerator, make a way for us to change the amount of time that our camera waits at the end. And to do that is quite simple. I'm just going to say yield, return, new, wait 4 seconds, and we will feed it in here a float which we will create at the top, and we will call this the rot switch time. I will just put this below the seconds to rot float. So public float rot switch time. We don't have to give it a value right now, but we will be using this float right here. I'm just going to copy it and I'm going to paste it into the wait 4 seconds, and that will allow us to dictate how much time the camera will wait at the end of its rotation. So just here in the camera rotation script, this will pop up. I'll give it a value of 2 just so it's very visible. When this gets to the end of a rotation, it will wait for 2 seconds. I'll just quickly demonstrate that, and then it will continue to do what it was doing before and doing its rotations. So now that's in, I would also like to adjust the pitch of the camera, because in most instances cameras are higher up, so we will need it to rotate down. Currently the way it is set to, you could adjust it manually, and I do believe that will work. Nope, it won't. It will automatically reset itself. But anyways, we're going to go do that in the code. So heading back into the code, we are going to change the position of the camera's head. And to do that, we are going to need a transform. So just at the top, I'm going to say transform. I'm going to call this cam GFX, which is basically just the graphics, the blue box of the camera. And we are going to change that a little bit in the start. So in start, I'm going to say cam GFX is equal to transform dot get child 0. And what this will do in our scene, in the way we have it set it up, is it will get the child of our camera pivot, which is this graphics object right here. And the reason I'm getting that is that I want to keep the pivot as flat as possible, so it's only rotating left and right. And I want the yaw, of the camera pivot, so that it's only rotating left and right. And I want the pitch to be applied to the graphics, so that we can manipulate the camera pivot itself, and there's no funny rotations going on. It's just one rotation happening here, and it's very easy to keep it tracked. But to head back into the code, we are also going to need to, now we have this transform, change its rotation. So I'm going to say cam GFX dot local rotation is equal to quaternion dot angle axes, and we are going to give this a value that we have not created yet, and this value will be called pitch. So just below yaw, I'm going to say public float, so we can adjust it in the inspector when we want, and I'm going to call this pitch. We don't have to give it a value, and we will feed this angle axis the pitch, and we will also give it a vector 3 dot right, I do believe, and this will set up our pitch from start. So if we head back into Unity right now, just wait for this variable to be exposed on the script. Did I save it? Oh, no, we have an error. I'm just going to quickly head back in and address this. Yep, I didn't close off the local rotation. Head back into Unity. Wait for the variable to pop up. And using this, I'm going to use this to directly change the graphics angle. So I'm just going to give it a value of 15 so that we can see it. And what this will do is it will rotate the camera on its X by 15. As you can see, the camera is slightly looking down. I'll make it a bit stronger so that it's more visible. And you can use this to set up whatever pitch you want on the camera, and then it will rotate and behave normally after that, so you can have it looking up or down. So from here, I do believe that's everything for the actual rotation script. So after this, we are going to want to actually make the collider of the frustum, sorry, collide with the player. So to do that, we're going to go onto the frustum, and I'm going to add a component, and I am going to call this detection. I'm going to create and add that, and then open that up to edit. And with this, we are going to do all of the detection code for the frustum and the player inside of here. And to do this, we are going to use a onTrigger stay function. So the update in this, I'm going to quickly change to onTrigger stay, and we are going to say collider, and I'm just going to call this col. And in here, I only want to make the actual detection to see if it is the player work if it is the player. So I'm going to say if our col dot game object dot tag is equal to our player tag, and to get the player tag, I'm going to create a string at the top. So I'm just going to say a string. This can be private. I'm going to call it player tag, and we will need to get the player tag. So in start, I'm going to say player tag is equal to game object dot find game object with tag, not objects, just object, and we are going to find that by typing it in player here as a string. So as long as our player is tagged as player in the, I'll just quickly go on there and click on the player. Just up here in the top left, as long as he's tagged as player, this will find the player. And with this, we are going to, we need to put on .tag at the end there and then close that off. And with that, we are going to use this string variable to decide if the collided object is in fact the player. And inside here, we will then, if we do hit the player, otherwise we'll do nothing. If we do, we will want to do a raycast, and to set up the raycast, we're going to say a vector3 direction is equal to col.transform dot position minus our a position that we will need to set up. And this will be, we'll quickly head up to the top and we'll create a new transform. And I'm going to call this lens. And this lens is the lens that's on the front of the camera, as that is what I was using to be the 4-point of the camera. Essentially, that's where I'd want the frustum connected. So with the lens, we will also need to tell this to get the lens, as that is private. So we're going to say lens in our start update is equal to transform dot parent dot get component, and we will get the transform. As our lens is a child of the camera head, I'll just head back into Unity there. Sorry, as the frustum is a child of the lens, if we tell it to get the parent, it will then get us this lens, which is what we want to get the direction from the vector3. So down here in the vector3 direction, we see a col is col.transform.position minus our lens.position. And what this will do is give us the vector3 that we're going to use in the ray check to give it the direction it needs to find where the target is. Below that, we're going to need a raycast hit variable, which we will just call hit, and we will then need to fire the ray. So we're going to say if physics dot raycast, and inside here you're going to say lens dot transform dot position, and we are also going to give that our direction dot normalized. We're going to put out hit, and we will give this a distance of, I'm just going to put in 1,000. You can make that into a variable if you want, but it's only going to collide with the one object, and it only wants to search for one object, so that seems to be fine. In all cases that I've had, it's way more than what the collider would allow anyways. But inside here, what we're going to say, I'm just going to do a quick debug dot log, and I am going to get the hit dot collider dot name. So this will, if our player is inside our collider, we will then fire a raycast from our lens position to our direction, which is where our player is essentially. And if it hits if the player is in and we are casting the ray, it will give us the name of the collider that we are colliding with. So I'm going to head back into Unity, and I'm going to clear out my console at the bottom there, as I don't like that red exclamation mark. And what should happen is when I press play, for all of the time the player is inside of the frostrum, we should get a little debug. As you can see, it did go 29 times there, because it is an on trigger stay. It should also be a case of if I bring the wall down, as you can see, this is called wall in the hierarchy. It is detecting that the player is being caught in the collider, but because the wall is in the way, it is not going to, it's showing that we can't actually see the player with that camera. It's not visually showing any representation of that, but we will go back into the code and quickly set that up. So to do that, we are going to put an if inside of this raycast. So I'm going to say if hit dot collider dot game object dot tag is equal to the player tag string we created at the top. If that is the case, I'm going to say lens dot get component. Of course, in here I would suggest whatever behavior you want for it, be it setting off an alarm, playing a noise, or making the enemy react to it. I would say put it in here. I'm just going to put this lens in, these calls in, just to show you that it is in fact working. So I'm going to say lens dot get component, and get component in parent, sorry, and we are going to get the mesh renderer from the parent, and we are going to change that material to be equal to a material that we have not created yet. So I'm just going to quickly head up to the top, and I'm going to create a public material, and I'm going to create two of them, so we can have searching mat, and we will have our spotted mat. So with them, I'm going to quickly assign the searching mat down here to the material of the lens. If we do in fact hit the player tag, I'm going to save that out and head back into Unity and quickly create two materials for this by right clicking in the window at the bottom and clicking on material. I'm going to just call it search real quick, and I'm going to right click and create a second material and call this spot. I'm going to give the searching material a yellowish tone and the spotted a red tone, just so we can differentiate between them both. So on the frostrum, right here in the detection script, we will want to assign the search material to the searching mat and the spot to the spotted mat. And I will also go onto the lens and quickly just put the search material on it, so that from the start it will be searching for the player essentially. I'm going to quickly go back on the camera pivot and set its pitch to 0, so that we are panning just side to side rather than up and down, so that we can see this working a bit better. And as you can see, the camera is yellow, and when we are coming across the player, it is in fact not changing. And why is that? We are detecting the player, but we are not changing the material. Let me just quickly head back into the code and find out why that is. The if we are equal to the player tag, hit collider. Oh, yes, that's because we are using searching mat here. Very silly mistake on my part. What we want to be using here, because we are in fact seeing the player, is using the spotted mat, not the searching mat. How foolish. I'm going to quickly save that and head back into Unity, press play. And what should happen is when the camera does detect the player, it should turn red. As we can see, it does. But it will not turn back to yellow as we have not told it to do so. So I'm going to quickly go back into the code, and we are going to need an else check here. We could do an else if, but again, we don't need to, so we can just use else. And what we are going to do is tell it that this call that we've made up here, is the lens docker component mesh renderer material. This is where we should have put the searching mat. Is that what we called it? I do believe it was. Yes. So that when we are not inside of this, sorry, what this will do is if there's a wall in the way, in the player is in the collider, it will in fact change the material. So as you can see, if it's red there and I bring it up as we're going through, it did change yellow. But there is the issue of that when it goes across, it will not change by itself, and that is because we need to create an onTrigger exit function, which we will do at the bottom. So just at the bottom here, below the onTrigger state, I'm going to say void onTrigger exit. And again, we will need a collider. I'm just going to change the other there to col. We will need to make a quick check to see if our col.transform .tag is equal to our player tag string that we created at the top, and if that is, we will want to do exactly the same that we have done up here in this else clause in the onTrigger state. We will want to tell it to go back to its searching material, and I do believe that is all the functionality for that. So I'm just going to quickly go back onto the camera and just demonstrate this real quick on the pivot. I'm going to change the seconds to rot to be 5 seconds so that we have a bit more time to play with this and see what's going on. And I'm going to create a bit more distance between the player and the camera. And from here, I am going to press play, and we will see the camera should go across the player. It should spot him, turn red, and then turn yellow when it can no longer see him. If I bring the wall down to block the view, we can see that the camera does come across and does not see, and it is telling us that it has seen the wall. If we allow it to partially see the player and then bring the wall up, as you can see, it is changing the materials. Of course, the material changing in there is not something I would suggest you necessarily having. That would be a place for you to call whatever you want the camera to incite. If you wanted to make an enemy come, or as I said before, make an alarm happen, you can do that. But I hope this was helpful to whoever has seen this, and I will see you guys in the next one. Bye bye.